We present multi-perspective visualization methods to improve navigation efficiency in augmented and virtual reality. We evaluate our methods in a study where participants perform tasks using a head-mounted display. In this first task, the user is asked to keep track of a red sphere target that moves in a virtual urban scene. Using a conventional visualization, the user has to move quickly, frequently, and over large distances in order to avoid occlusions and to keep a direct line of sight to the target. In our multi-perspective condition, the visualization disoccludes the intersection between the user's view direction and the ground plane by seamlessly integrating an overhead perspective into the user's perspective. The user rotates their head to track the target intuitively with little or no locomotion. In conventional visualization, disjoint regions of interest might not be simultaneously visible from any single viewpoint, and a sequential exploration of the regions of interest can miss important connections between them. In this second task, the user is asked to match targets of the same color. Due to occlusions, the user has to remember the color and location of a target while searching for its match. In our multi-perspective visualization, scene exploration ergonomics and efficiency are improved by alleviating occlusions to reveal multiple targets simultaneously. The visualization locks onto a first user-selected target, keeping it disoccluded as the user searches for the matching target. With the benefit of multi-perspective visualization, the user completes the task significantly faster. In this third task, the user is asked to walk the corridors of a real-world indoor scene in search of stationary targets. The user's exploration of the scene is limited by the tight turns at the intersections. The user has to walk to each intersection to inspect the lateral corridors. This sequential exploration is costly both in time and in physical locomotion. In our multi-perspective visualization, when the user looks at a portal marked with a rectangle, a secondary view swings into place to reveal what is visible through the portal. This way, the user can monitor an intersection remotely, avoiding unnecessary locomotion to intersections where there are no targets to be found. In this fourth task, the user is asked to catch moving targets. When a target sees the user, the target moves away. The task is challenging in the context of conventional scene exploration. The user can only find the target by establishing a direct line of sight to it, but that also triggers the target's escape. Our multi-perspective visualization allows ambushing the target. The additional perspective provides a preview through the portal without the user being visible to the target. In the interest of a perfectly controlled study, the targets used in tasks 3 and 4 are synthetic objects that are rendered in our multi-perspective framework. Here, the samples needed for the additional perspectives are acquired with color and depth RGBD cameras and are rendered as splatted 3D point clouds within our multi-perspective framework. In a surveillance scenario where RGBD video streams are acquired by color and depth sensors, additional perspectives are integrated into the user's perspective as a 3D point clouds using our multi-perspective visualization. We have described multi-perspective visualization methods for enhancing VR and AR scene exploration. The additional perspectives are managed by the user intuitively. Natural head motions allow selecting a street-level lookout point to be disoccluded, or allow bending rays through a portal to see around a corner. The additional perspectives are integrated seamlessly into the main user perspective without the visualization discontinuity, redundancy, and confusion of exploring a scene with multiple conventional images in parallel. A user study provides initial evidence that multi-perspective visualization can have a significant advantage over conventional visualization in augmented and virtual reality.